Hey everyone and welcome back. Today we're going to be talking about the node class and manual linking. We're going to show how we build these linked lists from scratch by creating those individual node objects and linking them together. We will try to do a little bit of visualization and build a simple chain, but if you're still struggling with it, head over to Python Tutor and try out building your linked lists in there. You'll get a really good visualization of what the heck is happening. So let's get started by building the smallest possible linked list that we can make. In order to do this, we are going to need that node class again, making our own object. Now, always make your values private. But for right now, I'm going to leave them as public just to make it easier as I'm coding through. But in the real world, or maybe even on your assignments, you need to make sure that you're making those values private. This is more of a do as I say, not as I do kind of situation. It's just going to allow me to make a really, really tiny node class so that I don't really have to worry about all the extra overhead of a constructor and accessors. So here we go. Every single node, as we sort of saw as an introduction to it in the previous video, has two parts. The data that we want to store, in this case, we're going to use integers, and a pointer or a reference to the next node. If next is null, that means that we're at the end of our chain. Let's go ahead and create some standalone nodes here. Node 1 is going to be a new node, 1.data. Actually, I guess that now is going to start to already be longer, and this is why we make node classes. We'll do it like this. This dot data is data. This dot next will just start off as null. One list, pass in a 5. There we go. So this list looks something like this. How about 2 list with a 10? This has a 10 and a next pointer for null. These are like 2 separate data points in a single node. There we go. And let's make a 3rd list, 3 list, new node, 15. And same thing, 15, and then the next pointer just points to null. 3 nodes all standing on their own. Right now you can kind of imagine them like 3 bricks sitting on a table. Each one is independent from the next, and they're not part of any structure. Now we start building the path. Let's take that first node, 1 list, and make the next one the next node. This is kind of like putting those 2 bricks together. After this line runs, 5 is still there, but this is now actually going to point all the way over to this node here. One way to draw it is like this. Another way people like to draw it would be like this, where this is representative of that dot next. So you might see them drawn nested like this, or you might just see them drawn like this, where each one of these is representative of that dot next. As soon as we assign a dot next, that new node gets chain linked together. Let's take 3 list and make it the new head of our list. We can do this by saying 3 list dot next is equal to 1 list. What does this look like? Well, first of all, we can draw it in this form factor, where 15 from here, now dot next is not null, dot next is 1 list. And what is 1 list? 1 list is that 5. And that 5's next is that 10. And that 10's next is null. If drawing it out this way is confusing, we can also do it in that nested format, where first we have 15 data, and what is it pointing to? It's going to be pointing to the node that has a 5 in it, and its next has the 10 in it and a null. We can see how this nested structure can start to grow pretty quickly. when in reality, what we are looking at is just sort of a list structure. Okay, so now we're able to actually see each of these data points. Let's verify that this works with some print statements. The first thing I'm going to print out is the front of my list. I'm expecting to get 15, as I can see right here. Let's go ahead and compile it and make sure that that's what happens. Perfect. After I print out 15, let's do this actually all on one line to get that structure the way we want it to look. Let's get the next one's data. This will then say, go into the 3 list, which is this node right here. In this example, it's this giant node right here. Go to the next and grab its data, which is going to be hopefully 5. And ideally what I'm going to do, this is going to be kind of annoying because I didn't make a 2-string, but here we are. That was my choice. Is I'm going to actually try to show it like this. Actually, we'll do it like this. Boop. There we go. Then I don't have to worry about those being tacked on. So now I should get 15 arrow 5. Perfect. I totally do. All right. What are we going to do next is we want to print the next one after that. Let's grab this information here and let's do this one more time. Only now, instead of .next, it's got to be .next, .data. What's happening here is we go into that pointer 3 list, which is this whole thing right here, and we're going to call .next, which is this whole thing here, and then we're going to call .next, which is this whole thing here, and then we're going to call .data, which will be this right here. So we should get a 10. I better save it before I try to run it. Perfect. And if we really want to finish it off so that it does look like this, we can go one step further and try to do this one more time. .next. Now it's worth noting here that this isn't going to work because 3's next is indeed this whole list in here. 3 next is this whole list in here. 3's next is this list right here. This null. Null does not have a data. This will give us a null pointer exception. Whoops. Null pointer exception, because that 3rd value in our list, or rather that 4th value in our list, is null. What we can do instead, if we still want to get this all printing out to match sort of the visualization I'm giving you, is instead just do next, since we know it will be null. If we do this, let me just clear this so we have a little bit more space, we can get that official list looking a lot more like what we expect. What we can see is we're literally walking through the chain by following these next pointers as we come through each one. The head of our list is this 3 list. It would be a good idea to name it something that would help us remember that. Head or top of list is always a good idea. And then we can, instead of saying 3 list, just swap these out here. And what we'll notice is that we always start at the head before we can go down to the next. We never want to lose our head reference. If we lose that reference, we're going to end up overwriting our list, and then the chain is gone. It's really helpful for us to have a mental picture of this. So make sure that as you're going through it, you are doing stuff like this, writing it out in the comments or drawing it out on your page. Nodes are actually pretty simple. They're just data and a reference. It's just like having your own name and then writing your address down and giving it to a friend. If we link enough of these together, we end up getting a list of data. The most important thing is that we need to protect the top of our list and always do our best to visualize it with those arrows, especially as it becomes more confusing in future implementations. In our next video, we're going to look at searching through these lists and trying to actually write some traversals so that we can go through them in a less manual way. Thanks everyone, and I'll see you there.